In this video, we learn how to change the subjects of a relation. To change the subjects of a relation simply means making a new variable stand on one side of the equation and all the other variables and constants standing on the other side of the equation. To change the subjects of a relation, we follow the following procedures. 1. Isolate the terms containing the new subjects. 2. Perform inverse operations. And 3. We simplify the resulting expression. Example 1. Make C the subject of the equation given below. Solution. We have the equation given as the square roots of C plus 1 all divided by 10 is equal to D. So here our focus is on C, right? To get rid of the square root, we have to square both sides, right? So we're going to have the square roots of C plus 1 divided by 10 all squared is equal to D all squared. Now let's simplify this expression. For the left hand side, the square is going to cancel out the square roots, right? And so we are going to have C plus 1 divided by 10 is equal to D squared, right? So we have to multiply through by 10. So we are going to have 10 times C plus 1 divided by 10 is equal to 10 times D squared. And so here, 10 is going to cancel out 10, right? So we are going to have C plus 1 is equal to 10 times D squared is equal to 10D squared. Now let's find C. So to find C, C has to be on its own, right? So we have to move plus 1 to the right hand side. So we are going to have C is equal to 10D squared minus 1. And so here we have C standing on its own on the left hand side of the equation, right? And so we've been able to make C the subjects of this relation. Example 2. Make E the subjects of the equation given below. Solution. We have the equation given as E squared plus F divided by 3 is equal to G. So here our focus is on E, right? So we have to make E stand on its own. First of all, you have to observe that this guy is a fraction, right? So we have to get rid of the fraction. Thus, we must find the LCM, then we multiply through by the LCM, right? Now here, the LCM is equal to 3, right? So you're going to multiply through this guy by 3. So we are going to have 3 times E squared plus F divided by 3 is equal to 3 times G, right? And so 3 is going to cancel out 3. Thus, we are going to have E squared plus F is equal to 3G. So here our focus is to find E, right? So we have to move F to the right hand side. We're going to have E squared is equal to 3G minus F. From the question, we are being asked to find E, right? Not E squared. To find E, we have to take the square root on both sides. So that's we're going to have the square roots of E squared is equal to the square roots of 3G minus F, right? Now here we have squared and the square root, so these two guys will cancel out. So thus we have E to be equal to the square root of 3G minus F. Thus E is equal to plus or minus the square roots of 3G minus F, right? Because when you take the square roots, you either have a positive number or a negative number, right? So that's why we have plus or minus in front. Example 3. Make H the subjects of the equation given below. Solution. Here we have the equation given as 4h minus 9 divided by 7 is equal to 2k. So this is also a fraction, so we find the LCM. The LCM here is given as 7. So you're going to multiply through by 7. Thus we have 7 times 4h minus 9 divided by 7 is equal to 7 times 2k. So here, this is going to cancel that. So that's you're going to have 4h minus 9 is equal to 7 times 2 is 14. So we have 14k. So our goal is to find h. So we have to move minus 9 to the right hand side. Thus you have 4h is equal to 14k plus 9, right? So to find h, you have to divide through by the coefficient of h. So the coefficient of h is 4 in this case. Thus, we are going to have 4h divided by 4 is equal to 14k plus 9 all divided by 4. Thus, h is equal to 14k plus 9 divided by 4. And so we've been able to make h stand on its own on the left-hand side of the equation. Thus, we've made h the subject in this equation. Example 4. Make k the subject of the equation given below. Solution. We have the equation given as 7 into brackets k minus 4 is equal to 5k plus j. So first of all, we need to expand these brackets, right? So we are going to have 7k minus 7 times 4 is giving us 28 is equal to 5k plus 5j, right? So here our focus is on k. So we have to group all the terms containing k on one side, right? So that's we're going to have 7k minus 5k is equal to 5j plus 28. For the left hand side, we are going to have 2k. So that will be 2k is equal to 5j plus 28. Our focus is to find k, right? So we divide through by the coefficient of k. Thus, we are going to have 2k divided by 2 is equal to 5j plus 28 all divided by 2. And so 2 is going to cancel out 2. So we have k is equal to 5j plus 28 divided by 2. Thus, we've been able to make k the subjects. Example 5. Make x the subjects of the equation given below. Solution. We have the equation given as 9z minus 5 divided by 2x is equal to 3x. So this guy is a fraction, so we need to find the LCM. So the LCM of these two guys is 2x, right? So you're going to multiply through by 2x. And so we are going to have 2x multiplying 9z minus 5 divided by 2x is equal to 2x multiplying 3x. 2x is going to cancel out 2x, so we are going to have 9z minus 5 is equal to 2x times 3x. 2 times 3 is equal to 6. X times x is equal to x squared, so we are going to have 6x squared. This equation is equal to 6x squared is equal to 9z minus 5, right? Here, our main focus is to find x, right? So we must first divide through by 6. So we are going to have 6x squared divided by 6 is equal to 9z minus 5 divided by 6. Thus, we have x squared is equal to 9z minus 5 divided by 6. We were being asked to find x, not x squared, right? And so to find x, we have to take the square roots of x squared, right? So we are going to have the square roots of x squared is equal to the square roots of 9z minus 5 divided by 6. And so we are going to have x is equal to plus or minus the square root of 9z minus 5 divided by 6. Example 6. The relation between energy E, mass m, and velocity of light v is given by E is equal to mv squared. Find the value of v when E is equal to 20 and m is equal to 5. Solution. Here we have the relation given as E is equal to mv squared, and we are being asked to find the value of v given the value of E to be equal to 20 and m to be equal to 5. So we must first make v the subject of this relation, then we substitute in the values of E and m in order to find v, right? So let's make v the subject. Thus, we are going to have v squared is equal to E on m, right? But our goal is to find v, not v squared. To find v, we have to take the square roots of both sides. Thus, we have the square roots of v squared is equal to the square roots of E on m. Thus, v is equal to plus or minus the square roots of E on m. So we now have the expression in terms of v. We now find the value of v when e is equal to 20 and m is equal to 5. Thus, v will be given as plus or minus the square root of e is 20 divided by m is equal to 5. So we are going to have plus or minus 20 on 5 is equal to 4, right? So we have the square root of 4. And thus our result is equal to plus or minus 2.